Science is rapidly evolving day by day, bringing us amazing news regularly. Today, we are going to discuss one such fascinating development. What is happening to the inner core of the Earth? According to scientists, the inner core's movement is slowing down and it is starting to move backwards. Research spearheaded by Dr. John Vidale, Dean's Professor of Earth Sciences at the University of Southern California's Dornsife College of Letters, Arts and Sciences, has confirmed a slow deceleration of Earth's inner core rotation to the point where it is moving backwards. Is this possible? How can this be happening? We are going to reveal everything to you, so stay tuned with us until the end. Let's start with the formation of Earth. About 4.6 billion years ago, Earth formed from a hot cloud of dust around the Sun. As the planet cooled, heavy elements moved to the core, while lighter elements formed the mantle. A thin crust formed on the surface. The mantle's heating and cooling cycle moves the tectonic plates on Earth's surface. Heat from the core broke the crust into these plates, which are always moving. The Earth is made up of three different layers: the crust, the mantle, and the core. The Earth's core is about 1,500 miles, or 2,414 kilometers thick, and mainly made of iron and nickel. It's very hot, with temperatures from 7,200 to 9,000 degrees Fahrenheit, or 4,000 to 5,000 degrees Celsius. Even with such high temperatures, the inner core stays solid because of intense pressure. Let's find out more about the inner core of the Earth and why it is so important. Earth's solid inner core was discovered in 1936 by Danish seismologist Inge Lehmann. She found it by studying earthquake seismograms from New Zealand, noticing that seismic waves bounced off the inner core's boundary and could be detected by sensitive instruments on Earth's surface. In 1940, scientists suggested that this inner core was made of solid iron. By 1952, Francis Birch analyzed the data and concluded it was likely made of crystalline iron. The inner core is a solid ball with a radius of about 1,020 kilometers, or 760 miles, which is about 20% of Earth's radius or 70% of the Moon's radius. Although it makes up less than 1% of Earth's volume, it holds about 10% of the planet's total magnetic field energy. It influences the liquid motions in the outer core and helps generate Earth's magnetic field. Without the magnetic field, life on Earth would be impossible. What is the latest update about the inner core that scientists are working on? Since its discovery in 1936, scientists have continuously studied the Earth's inner core. However, in 2023, there was shocking news. It describes that the inner core, which had previously spun faster than Earth itself, is now spinning slower. For a time, scientists reported, the core's rotation matched Earth's spin. Then it slowed even more, until the core was moving backward relative to the fluid layers around it. Experts say more experiments may be needed to confirm this, but an article published on June 12 in the journal Nature stated new evidence for this hypothesis about the inner core's rotation rate. Not only does it confirm the core slowdown, but it also supports the 2023 proposal that this core deceleration is part of a decades-long pattern of slowing down and speeding up. Dr. John Vidale, Dean's Professor of Earth Sciences at the University of Southern California, states, "We've been arguing about this for 20 years, and I think this nails it. I think we've ended the debate on whether the inner core moves, and what's been its pattern for the last couple of decades. How do scientists study this? Studying Earth's deep interior directly is impossible. Seismologists gather information by examining the behavior of seismic waves from large earthquakes that reach the inner core. By observing differences in these waves at different times, scientists can measure changes in the core's position and calculate its spin. Experts observed seismic waves produced by earthquakes in the same locations at different times for this study. They found 121 examples of such earthquakes between 1991 and 2023 in the South Sandwich Islands. They also examined core-penetrating shock waves from Soviet nuclear tests conducted between 1971 and 1974. The research revealed that the core is now spinning much slower and accelerates at different rates. When studying Earth's deep interior, seismic waves play a crucial role. There are two main types: P waves, pressure waves, and S waves, shear waves. P waves can travel through any material, while S waves only move through solids or very thick liquids. Back in the 1880s, seismologists discovered that S-waves generated by earthquakes didn't pass through the entire Earth, leading them to believe Earth's core was molten. However, they noticed something puzzling. Some P-waves emerged in unexpected places, creating what they called a shadow zone. In 1929, Inge Lehmann, studying seismic data from a New Zealand earthquake, proposed that these wayward P-waves might be interacting with a solid inner core surrounded by a liquid outer core. In 2023, researchers revisited this idea. They tracked seismic waves from earthquakes since 1964 that passed through Earth's inner core. They discovered that the inner core's spin follows a 70-year cycle. In the 1970s, the inner core spun slightly faster than the rest of the planet. By 2008, it began to slow down. And from 2008 to 2023, it even started moving backward relative to the surrounding mantle. Supercomputers played a crucial role, helping to perform calculations and analyze the data. The research revealed that the core is now spinning much slower and accelerates at different rates. Slowing down Earth's inner core rotation, how does it affect daily human life? The inner core, located about 3,220 miles or 5,180 kilometers beneath Earth's surface, is mostly made of iron and nickel and is as hot as the sun's surface. Earth's magnetic field, created by the movement of metal-rich fluid in the outer core, influences this solid metal ball, making it rotate. While we don't fully understand how the core directly affects the magnetic field, a slower rotation could potentially affect it and slightly alter the length of a day. As we mentioned earlier, there's a close link between magnetic fields and the inner core. Changes in Earth's magnetic field might influence sea levels. Moreover, these changes could possibly affect the climate, although this idea is currently just a hypothesis that needs more research to confirm. Maurizio Mattesini, a geophysicist specializing in Earth's internal structure, emphasizes that while there's suspicion about these effects on climate, there isn't concrete evidence yet. Researchers suggest there might be an impact, so further studies will be necessary to understand it better. Earth's magnetic field is dynamic, not static. It undergoes changes and occasional reversals where the magnetic north and south switch places. While it hasn't happened for hundreds of thousands of years, scientists continue to monitor for any signs of the next reversal. While research studies and confirmations exist, there is still ongoing debate about these facts. This underscores the need for more detailed experiments and information to fully understand the complexities involved. Scientists continue to work diligently on these challenges, aiming to provide better explanations and more comprehensive details. We're committed to keeping you updated on their progress. Did this video help expand your knowledge? If so, please hit the like button and subscribe to our channel for more updates. Until next time, stay safe.